Okay, guys, we are going to complete acids and bases exploring pH. The objectives: you will explore the pH and conductivity of various solutions of acids and bases. By varying the concentration, you will explore the effect of concentration on pH value. Conductivity testing will allow you to discover that both strong acids and strong bases are strong electrolytes, while weak acids and weak bases are weak electrolytes. We will measure the pH of each dilution and record the data in table 1. We will test the conductivity by inserting both electrodes of the conductivity tester into the solution to be tested. We will record the result in table 2. I need for you to use C for if it's a conductor, S for slightly conductor, and N for no, not, it is not a conductor. Alright, this is our pH meter. We are going to test HCl, hydrochloric acid. So you know the pH of distilled water is 7. So you write down 7 for the pH for distilled water. Hydrochloric acid, I'm going to measure 1 molar. Since all my numbers here will be in scientific notation, if I want 1 molar, let me put 100 times 10 to the negative 2, which is the same thing as 1. So I have 1 molar hydrochloric acid in the container. And I insert my probes, pH probes, in the hydrochloric acid and measure the pH. The pH is 0. Remove the probes. Now I'm going to dilute my hydrochloric acid. Instead of 1 molar, I will put 0.1 molar. I'm diluting it. So this is 10 times 10 to the negative 2 is the same thing as 0.1. And I insert my probe and I see the pH is 0.99. 0.99. I'm going to dilute this acid again. Instead of 0.1, I'm going to use 0.01. 0.01, which is the same thing as 1 times 10 to the negative 2. I insert my probes and check the pH. It is 1.99. Remove the probes. I dilute it again. Now I have 0.001 molar and I check the pH. It is 2.99. 2.99. Now, next, instead of hydrochloric acid, I'm going to measure the pH of acetic acid. Vinegar is the same thing as a solution of acetic acid. And I'm going to compare the exact same concentration. I will start with 1 molar acetic acid. 100 times 10 to the negative 2. And check the pH. And I see the pH is 2.37. 2.37. I'm going to dilute my acetic acid. Now it is 0.1 molar. And I insert the pH probe. And I see the pH is 2.87. I dilute it again to 0.01 and check the pH. It is 3.38. pH 3.38. Dilute it one more time. This is 0.001 and check the pH. And I see the pH is 3.90. 3.90. Now I'm going to check the pH of sodium hydroxide. Sodium hydroxide, and I will check the exact same concentration as for the acid. So I will check 1 molar sodium hydroxide. Insert the pH probe and check the pH. I say it is 14. Remove the probe. I will dilute it to 0.1 molar and check the pH. And I see it is 13. Remove the pH probes. Dilute my sodium hydroxide solution again to 0.01 molar. Insert the pH probes, and I see it is 12. pH is 12. Dilute it one more time at 0.001 molar and check the pH. I see it is 11. This was sodium hydroxide. Now let's check ammonia. Ammonia is NH3. Ammonia, remember, is NH3. NH4 plus is ammonium. Ammonia, NH3. Ammonium has one more letter. It is UM, one more letter. Therefore, it has one more hydrogen ion. That's the way you will remember the difference between ammonia and ammonium. So I'm going to check 1 molar solution of ammonia. 10 to the negative to 1 molar. So I insert the pH probe and I say it is 11.62. 11.62. Let's dilute it to 0.1 molar. Insert the pH probe and I see it is 11.12. 11.12. Remove it. Now dilute it another time. This is 0.01 molar. Insert the probe, the pH probe and the temperature probe, just to make sure it is at 25 degrees Celsius. Same temperature for all of them. And the pH is 10.61. 10.61. Dilute it one more time to 0.001 molar. We insert the pH probe and the temperature probe, and we see the pH is 10.09. Okay, so this is all the tests for pH. Let's check conductivity. Conductivity. The first thing we will check, distilled water. I will tell you right now that distilled water does not conduct electricity. Distilled water does not conduct electricity. Remember, we said to use C if it's conduct, S slightly, and N does not conduct. Even though I said distilled water does not conduct electricity, I don't want you to go home and put your blow dryer in the bathtub. Okay? Because the water in your bathtub is not distilled water. It has dissolved ions in it that will conduct electricity. So don't go and do it and tell your mom that I said the water does not conduct electricity. I can put it there. Alright? Don't do that. We will check hydrochloric acid and 10 molar. Since I have my number here times 10 to the negative 1, I will put a 100 here to give me 10 molar. And I close the circuit. I connect it to see if hydrochloric acid conduct electricity. I can see it conduct very well. Next, let's open and then dilute it to 1 molar. 1 molar. It is 10 to the negative 1. 10 to the negative 1, and we connect it, and we see it still does conduct. It is a good conductor. Disconnect, dilute it to 0.1 molar. 0.1. Check the conductivity. We say it still conducts electricity. It is a good conductor. Disconnect. Now let's check for vinegar, acetic acid. Acetic acid dissolved in water. We will check 10 molar. 100 times 10 to the negative 1, and connect it. We can see it is slightly. It's not as bright as hydrochloric acid. Not as bright. Disconnect. I change the concentration to 1 molar and connect. You see it's even lighter. Even lighter. Disconnect. Dilute it again to 0.1 molar. And connect. Very, very light. Very light. Disconnect. Let's check sodium hydroxide. Sodium hydroxide. And the exact same concentration. We will start with 10 molar. Let me put 100 times 10 to the negative 1. I connect. I see it is a good conductor. Disconnect. I dilute it. This is 1 molar. Connect. Still conduct. Okay, dilute one more time. Let me disconnect first and then connect it. Okay, still connect. It still conduct. It's still a good conductor. A little bit lighter, but it does conduct. Disconnect it. Now let's check ammonia. NH3 ammonia. Same concentration. This is 10 molar. 100 times 10 to the negative 1. And I connect it. It is not as bright as the sodium hydroxide. Disconnect. Dilute it to 0.1 molar. And connect it. Even lighter. I disconnect. Now I use 0.1 molar and connect it. Even lighter. Even lighter. So, based on your observation, so make sure you have the table completed. Make sure you have this table 2, the table 2 completed. And I need for you to answer those questions. It says, what trends do you observe in your data? What explanations can you come up with that might explain these trends? And as conclusions, how does reducing the concentration of an acid affect its pH? How does reducing the concentration of a base affect its pH? Relate conductivity to the strength of acids and bases. So make sure you complete this paper. And I also want you to go back and complete the Exploring pH Anticipation Guide. You were supposed to do the before lab before you watch that virtual lab. Now you go and answer the questions for after. Supporting evidence. Okay, agree or disagree, complete the Exploring pH Anticipation Guide. I want you to also complete Working with pH. Working with pH. I will call your attention on 4 formulas from that paper. Working with pH. It says, it says at 25 degrees Celsius, the KW value for water equals to concentration of hydrogen ion times the concentration of hydroxide ion equal times 10 to the negative 14. Let me repeat. You need to underline or highlight that formula. You will be using it. Concentration of H plus times the concentration of OH minus equal 1 times 10 to the negative 14. Another formula, pH equal negative log of the concentration of hydrogen ion. Another formula, POH equal negative log of the concentration of OH minus. And one more, pH plus POH equal 14. With those formulas, you should be able to complete the worksheet working with pH. So make sure you take care of yourself, and I will see you next class. Bye.